All right, good morning, everyone. How's everyone doing? All right, so analyzing the brain stress that we did this morning, looks like you guys did plenty of participation. So let's just go ahead and go over it. You guys are doing pretty well, right? So we're pretty much got this down by memory by this point. With our mole roadmap, with this problem particularly, it says how many grams of carbon dioxide can be formed if you have 5.2 moles of methane. So remember, what we start with is always what we know, and we know we have 5.2 moles of methane. So CH4, that's our moles of X. And then we want to circle our end, right, or what we're trying to solve for. So our end step is grams of carbon dioxide. So N goes over here, or mass of Y. And our middle step is that we first need to convert to moles of Y. And so converting from moles to moles is using that magic mole ratio, where we get two different values of moles from a chemical equation, as we'll see in a couple slides when we practice that again. And then finally converting from moles to grams or mass of Y, we're using that molar mass from the periodic table. All right, so let's just go over some reminders that, again, please don't share any personal information during class, guys. Your participation is required, and these sessions are being recorded for learning purposes. All right, so today is Friday. Yay us, we made it through the week again. All right, today is going to be another two-part lesson, but the first part of our three-step stoichiometry calculations. We'll get into what exactly that entails in a little bit. All right, but yeah, we have two lessons left in the unit. Let's go and talk about the tests again.
Yep, just a quick reminder that Star 360 again is next week for all students. Don't forget it is worth 5% of your grade in every single class, so please make sure that you get it done because it'll help boost your grade in every single class. It's a completion grade, it's not like on how well you do, so obviously try your best because that way we know whether or not you need any interventions or if you need extra live sessions and stuff like that. So obviously do your best, but again, just completing it will give you 5% in every single class. Reading will be done during this period on Tuesday, so come ready on Tuesday in this class to do Star 360. Star 360 Math will then be on Wednesday in whatever your normal period 3 class is. Please keep in mind that obviously we do have lessons for our other classes that day, so you're still responsible for completing that lesson. Star 360 should only take 20 to 30 minutes, so you'll have a little bit of time during class to get to work on that lesson, and or you can do it in the afternoon, right? It shouldn't be too bad to do that. It'll be a 20-minute video. You should be able to get that done. To prevent an exam occurring on the same day of Star 360, which we originally had, remember that we are combining Unit 4 and Unit 5 to make the Unit 4-5 exam on this Wednesday right here. You'll also have Thursday before we zero it out, so please make sure you get it done by then. However, after that, you'll have 1 week, and then the last day of school is on Wednesday, June 9th. Tell me in the chat, what time do courses close on June 9th, on Wednesday, June 9th? Awesome. I see Elijah in the chat. I see Micah in the chat. Let's get some more answers in the chat. Let's go, let's go. You should know this. What time do courses close? Courses close. You can no longer submit anything. It's the last day. Yeah, so 1 minute before midnight, actually. So please make sure that you don't wait until midnight to submit something. So again, 11:59 p.m. on Wednesday, June 9th. After that point, you will not be able to access any of your materials, and your course access will be limited after that as well. So please make sure you get everything in on that last day of school. Craziness. All right, this is a reminder that this is my last day here, so I am going on maternity leave at 4 p.m. today. I do still have office hours today, so if you have any last minute project questions, please make sure you come. I do want to make sure that you are successful on your projects before I leave. I'm going to miss you all, but I am also excited to get ready for this baby. So let's go ahead and go over our objectives.
All right, guys. So today we're going to identify those steps using the mole roadmap again, right? So we'll go over it again, but if you look at the mole roadmap, you'll notice that there are three gaps between moles and mass that we can take. And those three gaps correlate to the three steps that we can do for any stoichiometric calculation, right? And we will go over that today. So looks like a good amount of you have already done so. But if you haven't already, there's one half of the links. Let me get the other one. Here are the links for the notes again. If anyone missed them at the beginning of class, let's go ahead and raise our hands for the notes. All right, and then we will move on with the lesson. And for our brainstorm this morning, all right, in the chat, we're going to start with the left-hand question first. All right, what are the two possible mole ratios for fluorine and nitrogen trifluoride in the equation right here? So fluorine is that compound F2, nitrogen trifluoride, that's a big long name, but that is just NF3. Okay, and remember that the big numbers, okay, out in front of our compounds that are in pink denote how many moles we have, all right, for any given compound in that equation. So I'm underlining them right now. Now tell me which of those large numbers for our first mole ratio up here, which one goes on the top in the chat? Which one goes on the top? Thank you, Micah, Monse, John, Ronnie. Yes, thank you. So that's going to be 3 moles of fluorine. It was a little wonky right there. My apologies. Let's try this again. That is a 3. Okay, and then how many moles of nitrogen trifluoride do we need? Yeah, thank you, John. Yeah, the other one is definitely 2, right? So process elimination, but right, if it's important we don't get confused, right? Because it's not just the other number, because N2 still has a number in front of it, even though it's invisible. That would be a 1 for N2, but we're not dealing with nitrogen. We're dealing with definitely the product on the bottom, right? So that would be a 2 down here. And if we're reversing that down below at the bottom of the slide, what number goes on the top if we flip it? So now the 2 goes on the top. Excellent. And so process elimination, we know that it would just be the 3 on the bottom right there. All right. So hopefully mole ratios, that should be pretty clear now. They just come from those large coefficients we see in the equation. All right. So now dealing with the right-hand question in the chat, what are the 2 possible conversion ratios using the molar mass of nitrogen trifluoride that were given here? All right, so I will draw some reminders. Remember, the grams go here, moles. There's no number in front of moles, but I will ask you what that means. So what number goes on the top of our first fraction in front of grams? What number is that? What number goes on the top? That will be 71, 1 grams of NF3. And then because there's no number in front of moles, what does that mean? What do we put on the bottom? 2. Yeah, it's going to be a 1. So that's 71 grams over 1 mole. And then if we flip it, what goes on the top now? What goes on the top if we flip it? Just a bunch more ones. I should ask the other number first. Okay, now where does the 71 go if it's not on the top? Bottom, exactly. All right, so now for our first 2 questions in our notes, it's going to be number 2 is going to be the mole ratios. Number 3 is going to be the molar mass ratio that we just filled in as a class. Again, having a hint right here where the blank means 1 always. For number 2, right, we're going to have both of these are answers. Number 3, both of these are also answers. So there's actually 2 answers per question, all right? Be sure to raise your hands for number 2 and number 3. But I'm just trying to remind you that I believe for our quiz or our notes, there's 2 answers per question on this slide. All right, so reviewing the mole roadmap, as I promised we would one more time. So just to go over the rules one more time, for the same chemical, right? So if we're dealing with X or if we're dealing with Y, for the same chemical, the molar mass is what we use to convert between grams and moles. So if I want to convert from mass of X to moles of X or vice versa, that molar mass is coming from the periodic table, right? If it's a singular element, like just 1 atom of oxygen, we would obviously use that decimal number at the bottom of the element square. But of course, if we have something like water where it has multiple atoms, then we would need to add up all of those molar masses for that 1 compound. All right, but the only way to convert a different chemical, right? So between moles of a different chemical in the middle is using that magic mole ratio from the balanced chemical equation. All right. And that keyword balance is going to play an important role. So on the test, you might need to pay attention and see, is the equation balanced to begin with? All right. Because we haven't been practicing that as much. All right. But that's just a little reminder. Okay. So for number 4, we're going to write in that word balanced.
All right, everyone. So let's go ahead and actually try this out. We're going to do one problem together, and then the next one you'll be able to finish on your own. So the question is, how many grams of nitrogen trifluoride can be formed if you have 12 grams of fluorine? For now, we're going to go ahead and ignore the stuff in the parentheses. We'll use that in just a few moments. So ignoring all that stuff, tell me what is the number that I have, and what's the units and chemical that go with it. So find the number and tell me units and chemical. I see John coming in with the number, so I just need other people to participate and tell me what units, what chemical do we have. Thank you, Dima. I see Ronnie with the number. I see Micah with everything. There we go. Let's get Daniela, Peter, Jaden in the chat. Let's get Douglas in the chat. Thank you, Kathy. David. Thank you, Monse. Thank you, Andrew. I see you. Not asking for raised hands. Make sure you're participating in the chat. Excellent. Yeah, so taking a look here, the number that I have is 12, and the units are going to be grams of fluorine. So taking a look there, point for me on the board. Oh, sorry, actually, let me label this up here. So up on the board, this is going to be our fluorine side. This is what we're starting with. So point for me up on the board, should I be over here at my mass of fluorine or my moles of fluorine? If we're talking about grams, go ahead and point for me on the board. What am I starting with on my map? I see purple there, I see pink there, I see red there, I see green up on the board. Let's get some yellows. Get your pointers. There we go, getting people up there. Excellent. Yeah, so we're going to be starting out over here on the fluorine side with grams. Now let's take a look at what we are solving for. Go ahead and tell me in the chat, what am I solving for? Give me units, give me chemical. If you want to just use the abbreviation, that's totally fine. Because I know that's a big word to type out. So give me units and give me the chemical formula of what we are solving for. Thank you, Micah. Thank you, Landon. Thalia, we've got those, the chemical, don't forget the units though. Same thing, Ronnie, don't forget those units. Excellent, Thalia, good correction. Yeah, so we're going to be ending with NF3, our nitrogen trifluoride, and again, it's grams, so where should I be ending here? Should I be ending with my blue moles or blue mass? Point for me up there on the board. Absolutely. I see Jalen answering in the chat too. Yeah, we're going to be ending with the mass of NF3. Now point for me, what are the middle steps? This one should be easy. What are the middle steps? How do we get from start to end? There's actually 2 middle steps, so I should see those arrows flying back and forth. Yes, so we need to do both of these middle steps. Remember, you cannot just go from grams to grams. Again, that's not possible. You first have to get to the most important part of the roadmap here, which is to go from moles of the starting chemical to moles of the ending chemical. Let's do this. So in here, I'm starting off with 12 grams of F2. Put it over what number in order to turn it into a fraction? Tell me in the chat. What number do I need to put it over to turn it into a fraction? Anything over what is still itself. Oops. Yeah, anything over 1 is still itself, so great. All right, I want to get rid of grams of fluorine on the top here. So in the next step, it needs to go on the, what would be the opposite side? Thank you. Yes, on the bottom. Excellent. Now, I cannot yet go to a new chemical because first I need what units of the new chemical. Again, the important part of the magic mole ratio is the what unit. Magic mole ratio, what's the most important unit there? I need to get to what unit of the same chemical. So new unit, same chemical. What's that going to be? New unit, same chemical. Thank you, Micah. Need more answers. What's my next step? Yeah, we need moles, but again, of the same chemical. So moles of F2. Smiley faces, everyone, if that makes sense. We cannot yet go to NF3. We still need to get to moles of the starting chemical. Great, so we've gotten rid of grams here, Now, I need to plug in some numbers here. I need you to, in a moment, point for me on the board. What should I use that includes both moles and grams of NF3? Should I use the molar mass of NF3? Should I use the molar mass of F2 or should I use the chemical equation? Point for me on the board. What has both moles and grams of F2? Moles and grams of F2. Which of my three standardized things here has moles and grams? Thank you. I see green, yellow, yellow. One of my yellows is good. My other yellow, though, you're wrong. You're not quite there. Get up, go up a little bit, up a little bit. Yeah, we're not using the chemical equation. Remember, chemical equation only includes moles, so that's not going to help me. I need something with grams. You are absolutely right. I need to use the molar mass of F2. So what goes next to moles if our molar mass next to moles and our molar mass is a blank? What goes next to moles there? Yeah, so I should put 1 on top, and what number goes next to grams from my molar mass? What number goes next to grams here for my molar mass? Awesome job, everyone. Yes, 38. So that looks good. Now I'm at moles of F2. I'm at moles, so I can go moles to moles now of my new chemical. So tell me in the chat, what is my new chemical? I'm going to get rid of moles of F2 on the bottom. I need to get to moles now of my new chemical on top, which is what? Moles of what on the top? What am I solving for? Take a look at my blue side. Yeah, moles of NF3. That's what I'm solving for on top. Excellent. All right. Now, go ahead and point for me on the board. What will I use to go moles to moles? Should I use the molar mass or should I use the chemical equation? Which thing has both the moles of NF3 and the moles of F2? It needs moles of two different chemicals. So should I use the molar mass of NF3 or the equation? Excellent. Seeing some people. We already used molar mass of F2, so we shouldn't be pointing at that. We need something with moles. Only moles. Only moles. No grams. Only moles. Yeah, there we go. Perfect. We're going to use our chemical equation. Give me a smiley face emoji or a yes in the chat if you understand. This is the only thing that only has moles in it. No grams in here. Cool beans. All right, what number goes next to NF3? How many moles of NF3 are in the equation? Take a look at its coefficient. Coefficient right here. Yes, there are 2 moles of NF3. And how many moles of F2 are in our equation? Again, make sure you're practicing with us because you're going to have to do the next one on your own, so make sure you're with us. Practice makes perfect here. Yeah, we have 3 moles of F2. Beautiful. Now, I am at moles of NF3. Is that what I'm solving for? Where it says how many here. Is that what I'm supposed to be solving for? Moles of NF3? Moles of NF3? It says how many what? How many what? Is this what I'm solving for? Yeah, I'm supposed to be solving for grams. So no, I am not yet done. So I need to get rid of moles of NF3. But now I can go to a new unit of my ending chemical. Right? So we're at moles, so we're good to just now switch over to my ending units. And my ending units, you are correct, should be grams of NF3. Grams, oops, sorry, NF3 of here. Cool, so we're getting rid here of moles of NF3. We just need grams on top. Now, last one, what is my standardized thing up on the board that contains both grams and moles of NF3? What thing is always true that contains both grams and moles for NF3? I see green on the board. See yellow up on the board. See another green, another yellow. Yeah, just by process of elimination, thank you blue, thank you purple, we should know that what we have left over is to use the molar mass of NF3. What goes next to grams on top? What should I put next to grams on top based on the molar mass of NF3? Thank you, Dima. Thank you, Micah. Thank you, Landon. Let's get Elijah. Thank you, Thalia. Thank you, Daniela, Ronnie, Monse, Douglas, John. Yeah, 71 on top. And next to moles on the bottom is a blank right here. So blanks, I should plug in what? Blanks, I need to go ahead and plug in what? Yeah, just 1. All right, so I'm left with grams of NF3. Now, is that what I was solving for? Where it says how many, is that what I was solving for? Yeah, NF3 is nitrogen trifluoride, and you're absolutely right, I need grams of it. So this is going to be my final units right here. That looks amazing. Now we just need to do the math. So on top, grab your calculators. I need 12 times 1 times 2 times 71. What do we get on top? Again, make sure you have your calculator. Make sure you know how to use it because you have to do the next problem on your own. So make sure you are practicing with your calculators right now. What do we get on top? Yeah, exactly. On top, you should be getting 1,704. And what about the bottom? 38 times 3. You can include the ones if you want, but ones won't change it. So you can do 1 times 38 times 3 times 1, or just 38 times 3. What do we get on the bottom? Perfect. Yep, 114. We're not done yet, though. We have this fraction, but remember, fractions are just division in disguise. So let's do the top number first, divided by the bottom number. Top divided by the bottom, what is my final answer? Good. So we do need 2 decimal places. For those of you that are uncertain, because what you're seeing is 947 after there, we need to make sure we understand why we're rounding this up. So I have a 4 right here, but after that number, I have a 7. And is 7 a small number or a big number? Is 7 a small number or a big number? Yeah, 7 is a big number. So that means for number 4, should we leave it as a 4 or round up? If it's followed by a big number, should we leave it as a 4 or round up? Yeah, we're going to actually round it up. So this should rounds up to 14.95. So I did see many people typing that incorrectly, but just in case you weren't certain, I want to make sure we went over that. So our final answer here should be 14.95 grams of NF3. So taking a look here, first box, again, should be 14.95. Make sure you have both decimal places. And then your units here should be G space NF3. This is for number 5. You have 30 seconds to fill that in and to raise your hand. If you have questions, make sure you ask them now, because again, the next one you're going to have to be able to finish on your own. All right, so last question here. Let's go ahead and rock this one. So the question right here is, how many grams of hydrochloric acid are needed to produce 65 grams of lead chloride? Again, ignore the stuff in the parentheses, and for now, tell me, what number do we have? What's the units? What's the chemical? Okay, ignoring everything in parentheses. What's the only number we have? Give me its units and chemical. Yeah, so right here we're starting off with 65 grams of lead chloride. So I'm going to make this side over here, PbCl2. Tell me in the chat, am I starting at mass or moles of PbCl2? Am I starting at mass or moles if I have grams? Is that mass or moles? Perfect. Yes, that's going to be our mass. And what am I solving for? How many what? Give me units. Give me chemical. Again, feel free to use the abbreviation. I know abbreviations are faster to type. Unfortunately, Neuro doesn't tell me when you're typing, so I don't know how long is appropriate to wait sometimes. So I'll try to give you wait time. Thank you. Awesome. Jalen, Thalia, don't forget to include the chemical. Ronnie, great job fixing that. Or sorry, don't forget to include the units, Jalen and Thalia. Awesome, Thalia. Waiting on Douglas and Jaden, Douglas and Jaden, Peter, and Jaylin. What am I solving for? How many what? Waiting on Callie and Andrew in the chat. Karime. Go ahead and tell me, what are we solving for? Yeah, we're solving for grams of hydrochloric acid. So hydrochloric acid is going to be my new chemical. And again, grams tells us mass. So it should point for me on the board. What are my middle steps? This should be easy peasy because it's everything on the board, right? What are the middle steps? Yeah, so both of those need to happen, right? We first need to get to moles of our old chemical and then to moles of our new chemical before we can finally end up at mass. So let's go ahead and do this. Up on the board, 65 grams of PbCl2 are what we start with. Okay, I'm going to put it over 1 so that we put it as a fraction. That just makes it easier to visualize. In the next step, I want to get rid of grams of PbCl2. Where does it go? I want to get rid of it. It's on the top right now. Opposite side would be the bottom. Grams of PbCl2. Now, can I go to my new chemical yet? If I'm at grams, can I go to my new chemical? Yes or no? If I'm at grams? No, I cannot. First, I need to get into what units of my old chemical. I know it needs to be my old chemical, but what units do I need to get to first? Think about, what's this entire roadmap called? Yes, we first need to get to moles of our old chemical. So moles of our starting chemical right here. Now, we have 3 different standardized things. Things are always true. We have the molar mass of HCl, the molar mass of PbCl2, and we have a chemical equation down here. Point for me on the board, which of those things contains both moles and grams, specifically of lead chloride, PbCl2. I need both moles and grams of PbCl2. Thank you, green. Thank you, blue. Thank you, purple. Thank you, yellow. Yeah, we're going to use our molar mass right here. So let's use our molar mass. What goes next to moles? In our molar mass, what is next to moles? We have a blank. Blanks mean. Blanks mean. Blanks mean. Yes, Ronnie. Yes, Micah. Yes, Thalia. Blanks mean 1. And what number goes next to grams for our molar mass? Again, we're not getting the grams from the question. We need something that's always true. The only thing that's always true here is our molar mass of lead chloride. What number goes next to grams? Right here. Thank you, Landon. Thank you, Thalia. Yeah, exactly. That 278.1, exactly, Ronnie, Daniela. That's going to go next to our grams. Cool. So we've gotten rid of our grams of lead chloride. I'm at moles of lead chloride. So I still need to now go to my new chemical. So tell me in the chat. I can go moles to moles now to my new chemical. What is my new chemical? I'm going to get rid of my old moles, MOL, PbCl2. And now I can get to moles of my new chemical, which is what? Look at the blue side. Thank you, Landon. What is my new chemical on the blue side? Yeah, hydrochloric acid, HC, little l. So moles of HCl over here. Point for me on the board. Which of my 3 standardized things contains moles of both HCl and PbCl2? No grams. I don't want grams. Don't want grams. There are no grams that I'm looking for. I need something that includes moles of both hydrochloric acid and lead chloride. Yeah, only the chemical equation includes both of those and is always true. So right here, what number should I put next to HCl? Take a look at its coefficient. What number should I put next to HCl? Take a look at its coefficient. Hydrochloric acid's this one right here. Yeah, there's a 2. Awesome. And what number should go next to lead chloride? PbCl2. There's no number next to it. There's no coefficient. So that means it should just be a 1. Yeah, blanks mean 1. All right, we got rid of moles of PbCl2. I'm at moles of hydrochloric acid. Is that what I'm solving for? Where it says how many am I solving for moles of hydrochloric acid? No, we still need to get to grams. However, I am at hydrochloric acid now. So now this is really easy. So I get rid of moles of HCl on the bottom. And I can go directly to grams of that same chemical using what? Point for me on the board. What has grams and moles for hydrochloric acid? Which of my 3 things is always true? Contains both moles and grams. Yeah, exactly. The molar mass of hydrochloric acid. So what goes next to grams on top? Tell me in the chat. What goes next to grams on the top? We're almost there. Work fast. We only got a couple minutes left. Want to give you time to finish up this problem on your own. Make sure your calculator's ready. Yeah, 36.46 on top. And what goes next to moles on the bottom from my molar mass? If I have a blank next to moles, that blank means, thank you, Micah, thank you, Landon, Ronnie, Daniela, David, blanks mean 1. All right, we got rid of moles of HCl. I solved for grams of HCl. Again, from my how many, is that what I'm solving for? Should I be solving for grams of HCl? Yeah, absolutely. So that is my correct units. That looks great. So now all we need to do is do the multiplication on top, do the multiplication on the bottom, and finally do the top divided by the bottom. So on the top, you should be doing 65 times 1 times 2 times 36.46. Do not put answers in the chat. On the bottom, you should be doing 1 times 278.1 times 1 times 1. Again, you can kind of ignore all those ones. Anything times a bunch of ones will still be itself. And then do the top divided by the bottom. Again, don't combine all those steps. If you're not very familiar with how calculators work, that'll mess you up. Just do the top first, then the bottom, then do top divided by the bottom. You should have 2 decimal places and your units, 2 decimal places, so 2 numbers after the decimal. And your units should be grams space HCl. That is an L, not an I. L, not an I. Go ahead and raise your hands for numero 6 and let me know when you're ready. You have 45 seconds to finish that up. If you need help, we're in the Q&A area. Or if you just want to double check your answer and feel that confidence, go for it in the Q&A area. Before I let Mr. Bangle take over, I did want to just say that I have been really proud to be your teacher this trimester. I'm going to miss you all. I hope you have a wonderful rest of your trimester and then a very, very restful summer break because you have definitely earned it. Thank you so much for being such great students this trimester.
Great 3-step stoichiometry calculations. We'll have some more next week on Monday, kind of like to solidify this concept and to review it. But great job, everyone, for today. If you'd like to, just really quick, take out your colored pointers and tell us how you feel about the lesson. All right. If you feel positive about it, then awesome for you. If you feel like you still need a little bit of help, just remember that there is one last optional tutoring session this week. And yeah, all right. So great job there. All right. If you haven't already, go ahead and turn your notes. All right. Uh, and have a great weekend, everyone. I will see you guys next week.